You are about to listen to the full interview with Dr. Massimo Teodorani. Sections of it were originally included in our Hessdalen Lights episode. If you haven't listened to the full episode, we recommend you go listen first. It'll provide context for this interview. Dr. Teodorani is a distinguished Northern Italian astrophysicist, known for his extensive research in explosive stellar phenomena, involvement in the search for extraterrestrial intelligence, and study of anomalous aerial phenomena. With a Ph.D. in stellar physics from the University of Bologna, he has contributed significantly to astrophysics. He works closely with Project Hessdalen and dug deep into many different theories surrounding the origins of the light phenomenon.
My name is Massimo Teodorani. I am an astrophysicist and I have a Ph.D. in astrophysics. I've been taken at Bologna University, which is the oldest university in Europe. And I've been working years and years in astrophysical research, in particularly with stars that show explosive effects like supernovae, novae, cataclysmic variables, protostars. But I have been working also on SETI project, and extrasolar planets, both using optical telescopes and radio telescope, and also ultraviolet space telescope. So this is my activity. I have been a researcher. Now at present, I am an independent researcher, relatively, because I collaborate with several organizations abroad, in particular United States. And I have been a lecturer, professor several times at university teaching physics for some courses of master level. And I am a divulger of science. I published 24 books, and I give very often lectures of popularizing astrophysics, physics, quantum physics, but it's something more like academic level, but in a soft way so that everyone can understand. Parallelly, I've been working on the scientific study of anomalous light phenomena. Starting with Hessdalen lights, I did several missions there using instruments, and not only in Hessdalen but also in other places that showed similar phenomena in Italy, in Canada, in United States. So just to give an idea of, in my free time, I am an electronic musician and I play synths, and that's my hobby. So that's all.
Yeah, I was listening to your music actually before we jumped on. I really like it. And you have such an interest. You have so many interests and such a wide range of work that you've done. It's really impressive to see. You also have a really pretty deep discography of a lot of music you've produced over the years as well.
Yeah. It's I just enjoy in following the German school, Berlin School of Electronic Music. Very similar to Tangerine Dream and other group of that kind.
So how did you first get connected and learn about the Hessdalen lights? What was your first encounter with the phenomenon?
Oh, it was very strange, because the first time I got interested in Hessdalen lights, I was walking at a free market somewhere near here, and there was a desk of books, many books. At some time, one book fell from the desk because with my elbow, I hit it, and the book fell just on a page at the very end of the book, which was by Jenny Randles, who is a very serious researcher. And that book, there was an appendix with about half a page telling Project Hessdalen. I knew nothing about that before. It was 1992. I had just got my PhD title, and at some point it was very useful because I collected a lot of UFO books. I have to admit, I had something like 5,000, but honestly, I was bored by listening all those stories because, they're just stories. What can we do? What an astronomer can do with that? So we know the basic physics, photonic physics, so photometry, photography, spectroscopy, and radio spectrometry, magnetometry. We have all the know-how to measure this kind of phenomenon. The difference is that it's not stars that are very far away, but they are luminous objects in the sky with which that we can measure using our instruments if we are sufficiently lucky. Okay, clearly they are not objects with fixed coordinates, so it's they happen randomly in the sky. But there are some locations in the world, and probably Hessdalen is the most famous of all, which work like a laboratory, because this kind of phenomena occur very often there. So it's a good occasion to attempt some measurements as we did.
Yeah, and could you actually maybe give me an overview of what Hessdalen lights are for someone who maybe has never heard of them before?
Oh yes, Hessdalen lights are apparently spheres of light. Okay, so there is no structure. Normally, there is no structure. They're floating spheres that are seen in the sky, sometimes also very close to the ground, with different colors. Normally white. Sometimes they are red, also red and blue. Sometimes they are connected together. They're multiple, and sometimes their apparition is preceded by sort of very sudden lightning in the sky, something like flash in the sky that occur. So there are many, manifestations of this kind of phenomenon, and apparently it looks like ball lightning. Okay, ball lightning is just a light ball, natural phenomenon, clearly of which we don't know much so far. The difference between ball lightning and the Hessdalen lights is that knowing the distance of the Hessdalen lights and comparing with the statistics of ball lightning, we can say that Hessdalen lights are at least 10 times, sometimes 50 times bigger than ball lightning, which normally is like an orange or a watermelon. Okay, and Hessdalen light can be also 10 meters across. And the other difference between ball lightning is that it's a much scale. The scale is much bigger, and they can last much more. As a ball lightning can last only 30 seconds, maximum 1 minute. In the case of Hessdalen lights, they can last up to 1 hour sometimes, while they are turning off and turning on, because they tend to pulsate very often. It's not a stable light in general. And amidst this kind of apparently natural phenomenon, people there has seen, also including myself, structured light phenomena which show geometry and which show something that looks like a flying machine. It happened to me too, and I saw twice, probably thrice, the same thing. And the reason, we don't know what is the connection. Clearly, I have, speculations about that. The most reasonable and logical is that in Hessdalen, people tend to look at the sky much more often. So it could be a selection effect of the fact that people look more often the sky, and so you see also UAPs, unidentified flying phenomena there. The other exotic interpretation is that, well, if we are visited, I wouldn't be surprised that people would visit this kind of location geophysically because of the minerals that are there, like scandium, copper, zinc, and maybe because of some energetic phenomena that are produced by the ground. So maybe, who knows, to make just a joke, they could go there like when we go to make gasoline at a gasoline station or something. That's very funny, but we cannot exclude, but we don't have an answer. We only want data using very well calibrated instruments that we can control. Okay.
Yeah, you mentioned that the lights normally don't have a structure. When I was researching, I was surprised to find that there were reports of structured craft also seen, because I had always assumed it was just the ball lights. Can you give us a little bit more information on what those structured sightings are and kind of what do the craft look like when they are sighted?
People sometimes is posting reports which are very well described by Project Hessdalen website by Professor Erling Strand. And people is reporting several shapes. And one of the last one is like a cube in the air. Sometimes they see semisphere and some others triangles. In my case, I was not alone there. It was the summer, August 2000, so 23 years ago. I was with some colleagues. We were about 3 at a location and other 2 at another location 2 kilometers away. It was a triangle, and with the 3 lights at the vertices, with no light in the center, which came just toward us. And it was quite easy to look at it with a binocular, but we couldn't take any video because we didn't have a video camera there. We couldn't take photo because it was moving in the sky, but it was clearly a flying machine. What I can say is that I always have to try to be the devil advocate of myself. I cannot exclude that one could have been some kind of experimental drone. And there are several kinds of drones, especially American, but also European and Russian, that have geometrical shapes like a lozenge, like triangles, deltas or something. So we cannot exclude that. What left me perplexed is that this thing was just over our heads, very close, I would say, and it didn't fly away. It simply disappeared over our heads in the sense that those 3 lights turned slowly off. Another thing that we saw, it was just a few days later, a very little light, completely different, which was translucent, weakly luminous, so like a 200-watt bulb, which was very close to us, about 90 meters, as I measured with my steps in the morning. It was looking like a giant firefly, I would say. It stood still there, human height, for about 10 minutes. It was very close. I was able to take a photo in that case, yes. Another time I was with the 2 colleagues, physicists there, 2 years later, and we saw something that were a double red light, which was literally landing in the wood in the part that goes towards the Oyungen Lake. It just went down. We stopped by the car. There was no noise, nothing. So this is my witness. There are several other witnesses by people we spoke there with. Famous witness who are very reserved people. They are not types that would like to make money with their thing, but they wanted to speak with us scientists and tell us what happened to them. And it was really, like a close encounters of at least of the second kind. It was looking, so it's very interesting. It's not impossible that we are visited. In fact, Professor Avi Loeb with the Galileo project, with which I've been working, by the way, for 1 year, for a full year. Professor Avi Loeb is a prominent professor, and he accepts the possibility that we are visited. And what we need now is to demonstrate or to prove or disprove this thing using very precise sensors, instrument, taking data, using the same methodology that we use in astronomy. So,
one thing that you said that stood out to me was you're talking about how if we are being visited, that Hessdalen might be actually a good place for visitors to come because of all the minerals, and it might just be interesting, a geologically interesting location. I remember reading a report about a piece of land that had been cut out nearby Hessdalen. Are you familiar with that story and kind of what the outcome of that was, and if you think there could be any connection between the land that had been cut and removed and the lights themselves?
Well, I don't know the story that is around that rectangular cutting thing. I know anyway that I saw, because they do that in Ireland also. They cut that. It's not terrain. I don't remember the name in English, but it's something that is being cut, and when it becomes dry, is used to make a fireplace or something like that. Okay, so I cannot exclude that prosaic explanation. I don't know if there was a connection between light phenomenon and that thing, but certainly, well, it was really very strange. And there is a connection with the ground. There was a sighting of fissures of a light ball. In that case, it was a witness. And I went with a colleague there to take some samples of dust, and we had it analyzed at electronic microscopy and X-ray diffraction to try to understand what's there. And there were iron spheres of some micrometers of diameter that were not present in a control sample that was taken 10 meters away from there. They were only there. So there is always an explanation, okay? And these spheres can be of meteoric origin, okay? So it's difficult to say this is of alien origin or something like that, because there is always an explanation that is prosaic. And as you know, skeptical scholars always take advantage of this thing to explain everything. Sometimes they are right, but sometimes they are not. And they are going against the main goal of science, which is exploration and discovery. So, yeah, that's what I can tell you about that ground thing.
So how did you and Erling Strand first get connected and start working together?
Well, it happened 2 years after my PhD, and in 1993 or 92 or so. And it was a pleasure, because Erling was very kind. At that time, we were not using yet email very often. We were using email at university, but I was writing from home. I didn't want to show my colleague that I'm studying UFOs, these things, because there is a gossip, and there was a stigma or something like that. Anyway, Erling invited me 6 months later, about 1 year later, at a very prominent symposium which was kept in 1994. In spring 1994, there was a lot of snow anyway, in Hessdalen, and it collected a lot of scientists. It was about ball lightning, okay. So, and there were also two Nobel candidate physicists. So it was very important. That was the first time I met Erling. And from that time on, I involved Erling Strand and also Professor Björn Hauge in the group in which I was working at that time, at the Institute of Radio Astronomy of the National Research Council, involved with my colleague there. And so the Norwegians were involved, but they involved us in making a research. So in the year 2000, we decided to make a first mission of exploration, where my colleagues, electronic engineers, gave a significant contribution, installing very powerful antennas, working in the microwave range, and above all in the VLF range, very very long wavelength, which was very precious. I was engaged with trying to photography and video these objects and to take optical spectra, which I succeeded, even if it was very difficult, but I succeeded to obtain once a good spectrum of the Hessdalen lights. So the collaboration went on for about 9 years, I think, with between Erling, my colleagues, and myself. And then there was an interruption of these missions, okay, because we didn't have money funding. That's the main problem, okay. But the good news is that Project Hessdalen now has been revived with a new Project Hessdalen. Instruments have been are being refurbished. The old ones are there; they have been put in function again. At the same time, we already know what kind of new instruments and sensors we need right now using the technology of now for improving this research. For instance, like an all-sky camera, we didn't have that, or a pan-tilt zoom camera, which is able to zoom on and track the object and possibly take images, but also possibly spectra using fiber optics. In fact, I prepared a research plan that is published somewhere there in the Project Hessdalen thing, and also on my ResearchGate portal. And yes, and so this collaboration actively has started again. I don't have at present time money to go to Hessdalen, but I hope next year I will. Yeah.
Can you talk a little bit about the observation stations that are out there currently and what the planned upgrades are? Like what are the upgrades you're going to be doing to each of the stations?
In the past, since the year 2002, I think, if I remember, there was one observatory which was called Hessdalen Interactive Observatory, also Blue Box, which is a container where you have several instruments like controls of cameras, telecameras. That there were several cameras that were monitoring the valley at several points of the valley. There was a radar, there was spectrum analyzer, and also VLF antenna, very powerful, that was built by the Italian colleagues in the engineering part. The new thing that we want to install is, as I said, something like at least 2 cameras, all-sky cameras, and 2 pan-tilt zoom camera, which means something that is able to track now the object, not only to catch photos of the object in a fixed view field, but able to zoom on it and track it like when we are using a radar substantially, so that we can take exposure of these phenomena and also zoom on them so that we can have a much higher resolution of this kind of phenomena. For instance, in 1999, December 1999, the Hessdalen Observatory by Erling Strand, clearly, and these students got a very prominent phenomenon, which was practically a fully illuminated triangular light object, which was literally sucking a light ball inside. If we had had a pan-tilt zoom camera, we would have had a much better resolution and we would have seen what exactly it is. Not only that, but we would have taken a spectrum, because you can connect a spectrograph to that using fiber optics without any need to drag it due to the weight, mechanical inertia or something. So there are new instruments that will improve the quality of the data, and as it is being done with the Galileo project, there will be use of artificial intelligence to be able to promptly identify known phenomena like airplanes, birds, insects, flying bags moved by the wind, everything. So artificial intelligence is able to exclude instantly something, and so we don't lose our time for those, and we concentrate our attention only on this phenomena. Then there are electromagnetic instruments that we want to first, we're improving the VLF part. I will suggest a microwave spectrum analyzer, and fundamentally it is the same system that the Galileo project is using. Also acoustic measurement of acoustic waves, ultrasounds, infrasounds, and possibly also a radar.
One interesting upgrade I think you mentioned in your paper was possibly deploying drones as well that might be able to go and spot the phenomena. Is that kind of like a phase 2 of upgrades, or would that be something?
Yes.
Yeah. Maybe talk about that and how that would work if we were deploying drones from the observatory.
Well, yes, the master plan is incremental, okay, step by step, because we need first to demonstrate that we are able, that the instruments are working, that we are able to get the data and to publish them, okay, possibly on peer-reviewed journal, okay. Then we can go to the next step. Drones now, as you know, are very sophisticated. They have high resolution cameras, and it has happened many times that Hessdalen lights have been seen very close to the ground. I took at least 2 or 3 photographs of the phenomenon while the phenomenon was very close to the ground. So a drone with a range, possibly maybe 30 minutes would be enough, but now there are drones that can last 2 hours, and it would be beautiful. It can fly over and take images all the time of the phenomenon in a very close range. So that will be very important, and also not so expensive, because with $3,000 we can already buy a good little drone. Yes.
How, when you do look at the Hessdalen lights through through your different measurements, what is the is there any signatures of the lights that are unique in terms of the energy that they're putting out compared to other known light phenomena?
Yes, but we didn't find it yet. Well, we found something because the spectra, specifically of the Hessdalen lights, show a continuum. So show something that could be produced by total ionization of the atmospheric gas, okay, or anyway, a plasma, okay. But it's undulated. It's made of multi-peaked characteristic that is not seen in other phenomena like prosaic, like carrier lights, airplane lights. We don't see this behavior. And after we check the responsibility curve of the camera, of course, because we have to calibrate, we have to check everything there. But there is a characteristics which I am searching for in particular. Sometimes lights can produce spectral lines. And when you plot the spectrum on a graph that gives intensity versus wavelength, you have the lines like peaks, okay, that are jumping, and this way you can identify due to specific chemical elements, okay. Okay, so if you aim at a mercury vapor light, we already know the wavelength, and you see the spectral lines that are have one peak, another spectral line has another peak. I am expecting that if these lights are artificial objects, they might produce a very strong magnetic field. Okay, when a magnetic field is very strong and it's inside the plasma, inside the heated gas, this magnetic field makes so that the spectral lines are split in 2 peaks instead of 1. The separation of the 2 peaks is proportional to the magnetic field strength. So from the separation of the peaks, we can measure directly the magnetic field strength without knowing any distance, okay? Because in this case, it's at zero distance on the plasma, differently from a magnetometer where the intensity decreases with the inverse of the cube of the distance. In that case, no, you can measure directly. It's very important because if, in fact, I'm proposing a medium resolution spectrograph which is quite higher, much higher resolution, at least 10 times, 25 times bigger than the one that we used in the past, that can allow to resolve these split peaks, to measure the intensity, but also to make inference on a possible propulsion mechanism. For instance, if you suppose that you have a machine that is made of superconductor materials, okay, and so you can make it, crossed it by very high voltage of electricity without producing any heat, any resistance. In that case, you produce also big magnetic field. Okay, I am expecting something that is between 1 Tesla and probably maybe 100 Tesla. With that instrument, if it happens this, then we can make an inference about the propulsion mechanism. Otherwise, we make other measurement about chemical composition, about the continuum, about the shape of the continuum. We can have a lot of information. So we try to anticipate what we would expect to see, because in Hessdalen, there is no doubt that the artificial component, which is only 5-10%, is the most interesting. So we have to verify if it exists or not. Okay, but we have to measure. We cannot say, no, it's not possible, no, absolutely. No, we have to measure and to verify. It's very difficult. But with automatic instrumentation station observing 24 hours, we might have the possibility to obtain this kind of measurement. And this is only one, because not only we make this measurement, it's only an example, but we have to make measurement with instruments using simultaneously several instruments working at different wavelengths, at different mode, okay, and see how the time variation of this measurement are correlated, okay? Because from this correlation, like it happens in astrophysics, we can infer the physical mechanism of the phenomenon, let it be artificial or even natural. Because also the natural part is very interesting, okay? It can give, there is a big mystery. The mystery is that why this light, the normal, apparently natural light bulbs are so self-contained. Why there is no energy loss, okay? It's very important, because if we understand the energy mechanism, the physics of that, we can reproduce in a laboratory and also at the industrial level for our use. Maybe it's a very clean energy. So just to give you an idea.
Yeah, so I know there's been instances where the observer's been able to interact with the lights by using lasers. What was that interaction like, and what do you think the significance of that is?
Well, also here there is always a devil advocate that, okay, it was in 1984 by Erling Strand. He aimed a laser at, I'm telling just for listeners, he aimed a quite powerful laser against a light which was pulsating, and it happened that the light changed the pulsation rate 8 times out of 9, like if it was communicating. So it is interesting. The point is that, is it real communication, or it's a new kind of photon-photon interaction of natural origin? Okay, this happened also in Italy somewhere. I was with a friend. We aimed a laser, a green laser in this case, against a light that appeared somewhere close to where I am in Emilia-Romagna. And the light not only increased the luminosity, but also all of a sudden jumped from a point to 200 meters, going so fast that no one could do that, okay? So I have some theories about that. It's quite complicated, and I wrote an article for Cambridge Scholar where I'm considering several hypotheses, okay? Because we have to consider many hypotheses. We have to consider the most reasonable ones, okay? Namely, those that are based on published peer-reviewed articles. There is a point about plasmas. In 2007, a group of German and Russian scientists published a prominent article, technical article of physics on New Journal of Physics, which is, by the way, you can find it online. It's quite mathematical, where they demonstrated that plasmas, in particular conditions, when they interact with dust, namely they call it a dusty plasma, they start to behave like the DNA, the biological DNA, like a life form. And they also reproduce like the DNA. So they started to think, to hypothesize that the phenomenon of life can happen not only in carbon life forms or possibly silicon life form, but maybe also in plasmas. Well, I have been reading other articles and then I have put the things together. I am thinking about also a theory about plasmas by a physicist, quantum physicist David Bohm. It was his Ph.D. thesis, and he demonstrated that the plasmas sometimes behave like a whole, only one thing. Not many particles separated, but only one thing, one orchestra of particles. What other mechanism is happening similar to that? Well, you go in the brain. When you think that the theory by, what is his name, Nobel physicist Roger Penrose and Stuart Hameroff, who is a neurophysiologist, they made a model about consciousness in the brain, hypothesizing that consciousness moments are due to the fact that there are some particles inside the neurons called microtubules, which are entangled together with the mechanism of quantum entanglement. Now back to the plasma. My hypothesis is this. What happens if the same thing that is happening with the microtubules in the brain happens in the particles of the plasma? Because at that point, I would suppose, I could hypothesize that these plasmas are not only life form, but at some moment they could become conscious, possibly at the moment in which a laser beam is aimed against them, but not only a laser beam, because a reaction had been recorded also with a normal light, even flashlights, or even electromagnetic emission or radar or something. So you see, I have many interests and I try to collect all together and see how the hypotheses come out and what I can prove with the data.
When you say the plasma could become conscious, what do you mean specifically by that? Is that, you mean like self-aware of their surroundings? Are they part of something, a larger life form or consciousness? Like, how does that come into play?
Well, something like us, conscious, so capable to realize what it has around, okay? It's something like our own brain. So I don't mean consciousness in the spiritual sense, no. I don't mean that. I mean something that activates the mind, okay? Even the rational part of the mind, or intuitive part of the mind. So this is very exotic speculation, of course, of which I have no proof. But I have a plan also for proving or disproving this using a high-speed camera. A camera of this kind can record up to 10 million frames per second, okay? Clearly, we couldn't use that because the resolution then would be low. But if we use 5,000 frames per second, we can see if there is a fast variation. If encoded in the fast variation of the light, there is some message, there is some form of intelligence that can be analyzed by mathematical software like time series analysis, fast Fourier transform or something like that. We can measure that, so we can monitor this thing, yes, also in this hypothesis.
You mentioned there's quite a few natural explanations for the lights. Could you go over some of what those different natural explanations are that maybe we haven't touched on yet for what could produce the lights?
Probably the most famous is the piezoelectric theory, which is a trigger mechanism, okay? And this is the most famous. Why? Because it has been demonstrated with experiments in a laboratory, in particular by geophysicist Friedman Freund, German geophysicist Friedman Freund, working in the United States. He's a professor. He demonstrated that when you compress a rock with a strong pressure, that rock produces light, which is piezoelectricity, the same of the lighters, and also electromagnetic radiation. This light, it's energy, it's voltage that is injected in the atmosphere. And this is a cause of ionization of the atmosphere. In few words, rocks in particular conditions, especially if these rocks are quartz or basalt or other similar material, when they are subjected to stress, sometimes tectonic stress, they can produce piezoelectricity. And especially during earthquakes, of course, but not only during earthquakes. And so they inject voltage in the atmosphere, which is ionizing it and can produce light bulbs, but it does not explain the reason why the light bulbs are so self-contained. They should produce something like a flash of light and nothing more, because we have in physics a mechanism of the so-called adiabatic cooling, where the plasma tend immediately to expand and cools down, and so the light would last a fraction of a second, not more than that. So we don't know that, but the trigger is reasonable. Then there are other mechanisms. One is by a group of my colleagues, Monari, for instance, and this colleague, they think that the Hessdalen Valley could work like a natural battery, practically, where several elements, in particular copper and zinc, would work like a cathode and anode, with the conduction of electricity through a conductor, through water of the river, for instance. It's a nice theory, okay? It can be tested also in a laboratory. It's not been tested yet, but it's not convincing, because the energy that can be produced is only a few volts. Instead, these lights are minimum 20 kilowatt of power, up to 1 megawatt or more, as I measured myself in Hessdalen. So it's a theory. There are several others. There are theory about the structure of these lights. I also speculated about that, because if you have a light bulb that is self-contained, that is long-lasting, this means that you need a balance of two opposite forces, one that is inward and the other one that is outward. Inward, something like a gravity, okay, and the other pressure. So it's something like mini star, okay. And it's very interesting because the mechanism, what is the gravity? Mini gravity, what can it be? Maybe mini black holes? They are not impossible as a component of the cosmic rays. And you have that, and not only that, but when you have a collapse, of the atmospheric gas through these mini black holes, you have a collapse of this, you have an increase of temperature, so the atmosphere becomes plasma. And not only that, but the magnetic field lines that are frozen inside the matter, inside the atoms of the air, would be strongly amplified. This means that this magnetic field would work like a cage, able to contain the plasma even for a long time. Physics says that at some point they could explode. This happens with ball lightning, but at my knowledge, this never happened with the Hessdalen lights. Probably because if they're strongly rotating objects, I did another theory with a German colleague. You have openings on the polar region where you have emission of energy from the poles. So this keeps equilibrium, keeps balance. But if there is no, if the temperature increase, then you have like a bomb, okay? But this doesn't happen in Stalin. So there is this, then there is the theory of zero-point energy, namely the spontaneous extraction of energy from the quantum vacuum. And Dr. Harold Puthoff spoke about that, but also others. After all, our universe was a very little particle, atom-like particle, that was born from the vacuum, okay, like a fluctuation of the vacuum. One day I was walking near the river with my colleague, mathematical physicist, Dr. Arrigo Amadori, and he told, maybe ball lightnings are just failed universes. So they tried to become a universe, but they didn't succeed. And so sometimes we see this because the quantum void with a virtual particle is trying all the time to create a universe. Only a few are successful, like our universe. So there is this theory. And I think I told the most important, but there are also others, of course. And for now, I don't want to add too many.
I'm really interested in the idea of zero-point energy as an explanation. Can you maybe just give a little bit more information on what that really means and kind of what the implications would be if this light phenomenon was a manifestation of zero-point energy creation?
Oh, yeah, it's very, very, very important because at that point, not only we would understand the physics of the plasma per se, okay, what comes out, but we would understand the cause of this, which is clearly not piezoelectricity. And if nature is spontaneously able to produce energy in that way, we don't know how. If we understand how, then that would be the key for us to extract energy from the vacuum. In that case, we would have a very really free energy, like Nikola Tesla was hoping to do, and this would revolutionize our life, our propulsion system to go from to other stars, okay, to do absolutely many things, and sending to pension the sheikhs and their petrol, because at that time we wouldn't need it anymore. So it's extremely important. For now, there are mathematical models. There have been experiments like the Casimir experiment, where they measured a very sudden pressure between two plates that are very close. And that shows that it's energy coming from the vacuum. Models say that, but still it's very little energy, okay? We need a lot of energy, and the ball lightning and the Hessdalen lights produce a lot of energy, sometimes more than 1 megawatt, and some UFO so-called phenomena have been reported in a famous article by Dr. Jacques Vallée that measure up to 500 megawatts, okay? Something incredible. And where do they come from? So the subject is extremely interesting, important just for physics, because it's our future.
Are there any other global phenomena that you think are similar to the Hessdalen lights that you've studied or heard about?
Yes, there are several strange phenomena that are reoccurring in the world. One is the Min lights in Australia, in the desert of Australia. The behavior of the phenomenon is very similar. And others are in your country, in the United States, like in Marfa in Texas. There are strange lights that are seen most often near the ground. Clearly, hyper-skeptical said, this is Fata Morgana, this is current lights altered by Fata Morgana effect. But engineer Jim Bunnell, who studied very rigorously with some university researcher this kind of phenomena, has excluded completely that. And he's not a guy who is in love with his own theory. He's only a guy that doesn't work on an armchair, but he takes instruments and tries to take measurements. So it's very similar. But there are other lights that are spectacular, like Hessdalen, like in the Brown Mountain, United States, North Carolina. There is an astronomer who is controlling some video cameras, Professor Bruce Ketton, who is a director of the Appalachian Observatory, who is monitoring the area of the Brown Mountain, confirming that yes, there is a phenomenon. And he's a skeptical guy, by the way. Then there are other places like Joplin, where there are strange lights, and United States also, and some others in South America. The point is that if the behavior of this phenomenon is similar, namely light balls or strange kinematics, random movement or something, this doesn't mean that the mechanism is the same, because there are several mechanisms that can produce this phenomena. Some are the theories that I told you, and some others could be also radon gas is strongly ionizing. A radon gas coming from the ground can produce that, and ionizing phenomena of several kinds, even something that is flammable can produce that. So it can be different causes, and it's worth studying. But Hessdalen probably is the most interesting because it is the most studied in the world. There is a strong know-how for the use of sensors. There were being many missions, and so I think we have to concentrate there, and I'm very happy to be a scientific consultant of Project Hessdalen, so far responsible of the scientific part, the research part. I would like to do more, but unfortunately I'm far away. I have no money for the moment to go there, but I'm very friendly with Erling and with Fred, with Magnus and with Andreas, that I hope we see them together and we find something, and hopefully, money arrive, donations arrive, because everything is depending on the money, and we have the competencies, So people must not think only about UFOs, extraterrestrial or something. Could be that too. Whatever it is, it's extremely important and interesting. So who loves science, go to Hessdalen.
I know when the lights were first witnessed, I think in the 80s when they became really popular in the media, there was a pretty high frequency of sightings. Where are the sightings at now in terms of how often the lights are seen compared to when they first were reported by the media in the 80s?
Well, I can tell you that I have a chart. I did a chart recently in the 80s, starting in 1981, and then in 1984 and 85 there was Project Hessdalen creation. The frequency of the lights was at least twice bigger than it is now. So there is a decrease, slow decrease, but still, even now, the frequency of the sightings is 5-10 times more high than anywhere else in the world. The location were more or less the same. It's something like in an area that is 5 by 10 kilometers, something, like 50 square kilometers, I would say. I wouldn't exaggerate. The location didn't change with the time, more or less. Randomly they're there, but sometimes they seem to like more specific places, yes.
What do you think is the most notable challenge in this research currently for the Hessdalen project?
The most notable challenge people would expect, demonstrating that we are visited, That would be very important, but it's not the biggest challenge. The biggest challenge is the energy factor, to try to understand how such a big amount of energy can be self-contained for so long time. That's the most important of all, for two reasons. The first reason is that we can reproduce in a lab, and the second reason is that if they come from the quantum vacuum, then we would do miracles, literally, with our technology. So it's the energy factor is the most challenging part, the physics factor. Not only that, but also if it were propulsion mechanism from extraterrestrials, we could deduce from the way in which the physical parameters vary with time, we could deduce what is the propulsion mechanism. And so that is also physics that we could, and it's another challenge that's worth doing.
How can the public or people who are enthusiastic about the Hessdalen lights, how could they get involved in helping further the research?
First of all, it depends what they want to do, because if they want to donate and to be constantly informed of what is happening, as Project Hessdalen, there is a new website that is being built now. They can be informed all the time, okay? And not only, but when the cameras will get functional again, they can follow in real time what happens in Hessdalen. And not only, but if they have the patience to follow some videos, they might discover things that others don't discover directly from the video, because clearly it's very difficult to revise videos of 2-3 hours. Okay, you become catatonic completely. I tried to do that myself, and in the past I found something also in that way. So this is a way of involvement, and expecting that they give some donations. A pack of cigarettes, for instance, $5 or something like that, or we're begging, and that's what happens with science in general. Okay, others, students, for instance, students of physics, of astronomy, and of engineering, could find something very interesting if they want to make a master thesis there. There is a very brave professor named Erling Strand there. They could do it with me too for the physical part, and also Ph.D. thesis, making research, which would be extremely interesting. So they could be involved in a technical way, educational way and technical way, which would be wonderful. So clearly not, in my view, not as a vacation. Oh, we go there, we see the aliens that are landing, maybe one day we see something. Well, that's nice, of course, but my opinion is what I told you, that is more constructive.
Yeah, you mentioned the video, helping review video. Is there plans to open up more of the other data as well for people to be able to review if there's people who are interested?
Yes, of course. Also, we have been planning to put when we will be ready with the new instruments, but very soon the new old camera will be reactivated. Erling is just working right now there in Hessdalen, helped with some colleagues. Also electromagnetic data would be recorded, possibly on the cloud, and if there is authorization to go to the cloud, people could take data from there and make research, search for correlations, for something staying from your armchair. Theoretically, you can do that. So it's extremely productive. It's like to have, to have a probe on another planet, and the probe is sending data all the time. Okay, so you get at home and you take the data, you put on a chart, you do calculations on something.
Okay, yeah. Last question, and then I'll let you go. But you mentioned that Erling is actually in Hessdalen right now doing some work. Can you talk about what that work is and what he's doing there this week?
You mean the work that is being done right now?
Exactly, yeah. The work that's happening right now.
Oh, yeah. Unfortunately, I'm not there because I would like to help. They are just putting in function again the old cameras that have been stopping for some time for the lack of funding, and that now they're reactivating the old thing. At the same time, we are asking funding. I've been asking funding for very specific instrument that we want to add when when the funding will come, we already know what we have to do. We already did a numerical simulation calculations and everything.
Before we go, is there any last thoughts or anything else you want to share about Hessdalen lights that we haven't touched on with listeners?
Whoever decides to study this kind of phenomena must have two qualities. Rigor. It means be very accurate experimentally, okay? Be mathematical. It's not stories here, it's not ufological story, it's just physics. And the other one, be open-minded enough that your brain doesn't fall from the skull, okay? So to be open-minded in a healthy way, okay? So a healthy skepticism is very important in this research, yes.
A special thanks to Massimo Teodorani for allowing us to use his music as the underscore for this episode. You can listen to more of his music under his artist name, Totem Tag, on Bandcamp. A link is in the description. If you enjoyed this episode, please leave a review on your favorite podcasting app. It helps get this content in front of more listeners, which means we can produce more episodes more often. Visit our website at www.strange-phenomenon.com for a full list of sources and more episodes. Strange Phenomenon is hosted by Ray Tarara. It's written and produced by RJ Blake and Ray Tarara. Theme music by Tara Monk.